This is preFlight, a 3D printing slicer with features I've never seen before. And in this video, we're going to explore what this brand new pressure slicer fork can do and put its features to the ultimate test to see if it's worth switching to. Let's get started. How's it going, guys? Angus here from Muse, and this is preFlight, a slicer for filament 3D printers developed by Muse, a US startup. I've been wanting to talk about this slicer since I was first introduced to it late last year, but unfortunately it was way too buggy to use at the time. But preFlight has just hit its 1.0.0 release as of time of recording, and it's now quite usable indeed. So I think it's time to take a closer look. preFlight is based on Prusa Slicer, an open source slicer for 3D printers which owes its beginnings to Slicer, that's Slicer with a 3, which is a slicing engine from well over 10 years ago. These are all open source projects, and preFlight is one of many Prusa Slicer forks. I'm talking huge projects like Bamboo Studio, Super Slicer, and even Orca Slicer, which has evolved into a powerful standalone slicer in its own right. Now that's a lot of options, but it's preFlight's unique features that really grabbed my attention. Visually, preFlight looks like a confused hybrid of Prusa Slicer and Orca Slicer. It's reasonably modern looking, but could definitely use work. You have your printer, filament, and slicer settings in separate windows along the top, like Prusa Slicer, but then you also have them on the left side in tabbed columns. And your model manipulation tools like move, rotate, and scale are on the right hand side. Up top you have add, remove, and nest features, and pretty much all of these have hotkeys assigned to them, which I recommend learning in any slicer so you don't have to go for a treasure hunt each time you want to use them. There is quite a lot of redundancy here, and there are way too many slicer settings to just shove into one huge scrolling column on the side. You can switch to an accordion style view, but honestly, it didn't make the settings any easier to navigate. If you could expand or collapse the slicing categories like layers and perimeters, infill, etc., I think that would make it much easier to navigate. But for now, I honestly just hide it and use the top tabbed windows, much like you would in Prusa Slicer, because again, there are a lot of print settings, and many of them are new and unique to preFlight. And we'll start with by far the most interesting: perimeter interlocking. Perimeter interlocking is a novel approach to solving a fundamental problem with 3D printed parts. The interface between layers is always the weakest part of a print. You see, as each layer builds on top of one another, that plastic has to melt and bond to that previous layer, which has already begun to cool and solidify. This intra-layer bond, along with voids in the part itself, creates an inherent weakness in the part in that direction, much like a wood grain. Perimeter interlocking attempts to overcome this problem, increasing the strength of this bond by staggering oversized extrusion lines across layers inside the part. These extrusions are offset each layer and over-extruded quite significantly so that the molten plastic can actually squish down between the gaps left in the previous layer, creating diagonal bonds that Muse estimates should give a 5 to 15% strength increase with no real change to material use or print time. This is really cool because stronger parts at no extra cost is a big win, and it also skirts the legal issues plaguing bricklayers, which is another method of increasing intralayer bonding, and honestly it may even be superior because it doesn't need the hundreds of micro Z-height adjustments that bricklayers relies on. I recently made a video demonstrating a somewhat hacky approach of doing this kind of thing in Orca Slicer, taking advantage of the alternate extra wall setting, and it worked really well for the PLA discs in my tiny combat robot, but to my knowledge, preFlight pioneered the concept of interlocking perimeters, and unlike the Orca Slicer approach, it creates the correctly spaced extrusions regardless of external part geometry, which often messed up the method in Orca Slicer. With the bold claim of 5 to 15% increased part strength in mind, I designed and printed these test pieces. And the original plan was to push them to the limit to see how much force they could take before breaking, but that didn't exactly go to plan. After setting up the part with the intention of using my standing desk to provide the load, I began with the first and presumably weakest test part, which had 100% rectilinear infill. Much to my surprise, however, this quickly overloaded the luggage scale, which then slipped and violently pinged off, and it broke. Not the part, mind you, that's completely undamaged, but the scale is busted. I do really want to repeat this with a less janky setup, so let me know in the comments below if you'd like to see that, because I'm going to need some time to build something proper. But even without being able to test these parts to destruction, I did notice something really interesting. The part from preFlight with the perimeter overlocking was by far the lightest, which isn't what I expected at all. It comes in at only 38 grams, while both the prints with 100% perimeters and the one with 100% rectilinear infill came in at 44 grams. And the part using my custom Orca Slicer settings to create a similar staggered perimeter effect was actually the heaviest, just slightly, at 45 grams. That is a 7 gram difference for the same part, which means that the one using preFlight's interlocking perimeter settings still has quite a bit of air in it, but any difference in part strength is yet to be seen. Another feature in preFlight that's a real time saver is counterbore bridging. If you ever had to print a detail like this, then you'll know the struggle. FDM 3D printers have the unique ability to bridge gaps with molten plastic, stretching filament lines from edge to edge to form a solid foundation for the next layer. And it's really useful, but only works if the bridge is in a straight line. If you have a counterbore detail like this, it completely ruins it. Instead of bridging across a nice straight line, the printer tries to form the bore in thin air and run filament strands to the edge of it. Needless to say, this fails spectacularly. Thankfully, you can solve this problem with clever geometric tweaks you add during the modeling stage, and I've even got a whole section on how to do this in my ebook, linked below. But preFlight now gives you the ability to solve unsupported counterbores right there in the slicer using a clever technique called sequential bridging. To use it, you select the underside face of the counterbore you want to bridge, and you choose how many sequential layers you want. The more layers, the more unsupported the bore will be, but obviously the more layers are needed to then build up that support. This is what it looks like with a minimum of 2 bridge layers. The first layer creates 2 bridge details which form the main support structure, and the second bridge layer fills in the remaining edges, giving a squared profile which the bore is then printed over. For small bores, I'd say up to 6mm in diameter or so, 2 bridge layers is perfectly fine, but if you're trying to support a much larger counterbore, something like this for example, you'll need to increase the bridge layer count, otherwise you'll still have overhanging details and the print will still droop and string. You can model sequential bridging details by hand, but having the ability to add these details in the slicer itself is a huge time saver. And unlike sacrificial bridges, which is my current go-to method, you don't need to drill them out after the print is complete. Big props to Oozbot for adding this widget in, and I have no doubt that other slicers will be following suit very soon. The last big feature I want to cover solves another annoyance I've had for years: seams. Print seams constantly ruin the accuracy of the bores in my builds, and it's caused me to start adding tiny V-shaped cutouts in the design itself to force seams into them and away from the bore itself. This works really well, but again, you have to model it in, and it's not always possible nor convenient. Well, now you don't have to bother anymore because preFlight has a setting for it called Nip and Tuck Seams. Nip will move the start of the perimeter into the print slightly, and Tuck does the same, but with the end of the perimeter instead. When used together, it creates a tiny V-shaped detail which effectively buries the seam out of the way, preventing it from interfering with the geometry and precision of that bore. I love this feature. It works awesome, and in my opinion, it's even better than scarf seams for practical printing applications. No, it doesn't hide the seam visually at all. A well-tuned scarf seam is still much superior for that, but it does effectively remove them from ruining the precision of those printed parts, and I'm honestly surprised that no one's done something like this before. Or maybe they have and I missed it. Definitely let me know in the comments below. There is a lot going on in preFlight and more being added all the time, but I want to see if it could give me a genuinely better printed result than I'm getting out of Orca Slicer, which is my current go-to slicer across all my 3D printers. And to test it, well, you know the drill by now, I printed a tiny combat robot. This is the chassis for Violent Crumble, my 150 gram plastic class ant weight. And this little machine's proven so effective, I wanted to build a version for the unrestricted ant weight class with a TPU chassis and metal weapon blade. So I modified it to be printed from 72D TPU, which is a really durable semi-flex material. And it has top and bottom plates made from PCB material from this video's sponsor, PCBWay. PCBWay makes custom fabrication easy, from CNC machining to laser cutting, 3D printing on industrial machines, and naturally, PCB fabrication. And believe it or not, the material most PCBs are made from, called FR4, is actually a pretty strong fiberglass composite, and it works great as a budget alternative to carbon fiber for these tiny little robots. It's rigid, fairly lightweight, and oh so affordable. 5 of these top plates from 1.6mm thick material came to $6.50 plus shipping, and were done in only a couple of days. You will need to modify your design for the PCB fabrication process, but it is really easy once you know how. I first extracted the part profile by creating a sketch and projecting the outline and through holes. Then I went to create PCB, derive PCB, and selected that new profile and hit OK. From here, you can then switch to 2D PCB, making sure you save it first, and then head to manufacturing, export Gerber, and hit OK to create the zip file you'll need to upload to PCBWay for manufacturing. It is that simple. Now, this is an unusual use of PCBWay's fabrication process, so I find it handy to leave a comment letting the engineer know that the traces and silkscreen layers are intentionally blank, but they'll let you know if there's any questions or comments before they proceed with the order. Combined with their CNC and industrial 3D printing capabilities, PCBWay is your one-stop shop for awesome builds, so why not give them a shot for your next project? And you can use code PCBWay-MakersMuse-10 to get $10 off any order of $30 or more. You can find more information in the video description below. A big thanks to PCBWay for sponsoring this video. Now onto the slicing. So here I have the project file for 3D printing the unrestricted version of Violent Crumble. This is the chassis to be printed from 72D TPU. And I'm not gonna lie, getting to this point with something that works was a huge pain in pre-flight. It was pretty challenging at this stage, but I did get it to work, so I'm gonna walk you through all the things I've done. But let's first take a look at the preview. So I've made this print take advantage of a lot of the features within pre-flight, starting with the interlocking perimeters. It's going not all the way, it's not solid, but it's got quite a few of the interlocking perimeter layers, and then a sparse cubic infill between them to add a bit of strength, but keep it fairly lightweight. I've also taken advantage of the counterbore bridging tool. As I mentioned, I usually do this sort of thing with sacrificial bridges, so it'll bridge across the bore and then I just drill it out after the print's done. But with counterbore bridging, it removes that additional step, so the print's ready to go right off the machine. And it does that by doing these really clever sequential bridges. So for example, it goes up one here, it will do 2 bridges across to start supporting that bore. Then for the next layer, it'll do another 2 bridges, which forms that little square cutout. And then the ball will just form on top of that, and it has much more support than it would have had just printing over thin air. And you'll notice I'm actually using 2 different kinds of manual supports within the same print, and that's something else you can do in pre-flight. You can do manual paint on support material, and you can choose what support type will be painted on where. So you can have grid, organic, or snug, and you can have any combination of these all over your model. So what I've done with this print is for this area at the bottom, which just has a really steep, sharp overhang, I've painted on some grid supports, and for that bore on the side where the LED goes, I've got some organic supports there. But as I said, getting to this point proved to be very challenging, because although the configuration wizard is available within pre-flight, the Prusa Slicer configuration wizard, it didn't work with the Prusa Core 1. It brings in a really nice looking profile, but none of the new settings work, like the interlocking perimeters don't seem to function or register at all. It's very, very strange. So I had to build one from scratch, and I did that by actually importing a configuration bundle from Prusa Slicer. Because although there is an Orca Slicer import option, there's a lot of issues with it. It imports very little, and that's probably just because Orca Slicer is so fundamentally different in how it works to Prusa Slicer, and as such, pre-flight, which is built on Prusa Slicer. But one of the most annoying bugs I came across that resulted in me just having so many failed prints was to do with print speed and the volumetric print speed setting just not working properly at all. You see, when you're printing with flexible filaments, you need to print slower than you would other materials because flexible filaments, as you force them into the hot end, can bend and stretch and jam up really easily if you push them too fast. Now, normally in modern slicers, what you do to slow your print speed down is to change your volumetric flow rate, which is how much material can be melted out of the nozzle at one time, expressed by cubic millimeters per second. So what I was doing in the version 1.0.0 is I was trying to change that setting instead of changing every other single speed setting because it was printing too fast and jamming. For whatever reason, this setting was buggering everything up and causing the printer to print even faster than if I didn't change it at all. And I'm talking about reducing it to like 3 cubic millimeters per second. And then it would start trying to print at 300 millimeters per second print speeds. Insane. So thankfully, as of a couple of days ago, a beta came out for version 1.0.1 or something. And that seems to have been resolved. So since doing that, I've done some tweaks to my settings. Again, I've had to basically build it from scratch, importing from Prusa Slicer, but I've managed to get some fairly decent results out of this machine. And the final print is a little bit stringy. I did have avoid crossing perimeters on, but I also had the material out from the dryer for 2 days as I tried to troubleshoot these issues. So it's actually not too bad for a TPU. And I'm going to see if I can get the weight to work in the robot once it's complete. But overall, the print looks really good, and it seems to be really strong as well. Now, time will tell if it's stronger than normal print settings or even my modified print settings out of Orca Slicer, but I did get it to work. Unfortunately, the process of getting to this point was way harder than I expected. So, should you drop your current slicer and move to preFlight? Well, no, probably not. At least, not yet. I absolutely love the direction that Oozbot are going in with this Prusa Slicer fork, but in its current state, it's a buggy hot mess. The slicer does now plug into the Prusa Slicer configuration wizard to load in printer and filament profiles, but some of them, like the Prusa Core 1 profile, didn't seem to respond to the new perimeter overlocking settings. For some reason, the new Athena perimeter generator wasn't responding or something. And although Orca Slicer import with conversion is now possible, I found that most of the values don't make it over, particularly for filament profiles. So it honestly just took less time to rebuild the profile from scratch by copying across values. And unfortunately, there was a host of other bugs and glitches, like modifiers completely breaking things, and random layers missing or infill phasing through perimeters unless you changed the perimeters while overlocking setting from the default value. And it only happened on some geometry. It's also quite chuggy while slicing with interlocking perimeters enabled, and the 3D Slicer preview window becomes incredibly laggy and GPU intensive the more you zoom in. And mind you, this is on a system with 64 gigs of RAM, an i9 processor, and a 4070. And I did play with performance tweaks, but they had no real effect. So some optimization is obviously still required. And yet, with all of those bugs, I still kind of love it. It's nostalgic to the early days of 3D printing when all slicers were like this. If you wanted the latest and greatest features like, oh, I don't know, support structures, yeah, I remember when Slicer first introduced those, then you just sucked it up and learnt how to work around the issues. Save often and crash even more often. And you should have seen the insanity I was able to achieve in Mesh Mixer with that principle in mind. Competing against the likes of Orca Slicer is a big ask, and I think for most people, that's where they'll stay. I saw a lot of comments saying that the Oozbot team should have just submitted their changes to the Orca Slicer GitHub instead. And yeah, I do think a lot of their widgets will eventually make it over, but we really do need little startups like Oozbot to shake things up for the better now and again. So if you like to experiment and don't mind the crashes and possible print disasters, then I highly recommend giving it a go, because they need the support to improve and have already fixed many of the bugs I first encountered trying to use preFlight late last year. And if you want to continue empowering your creativity through technology, then make sure you subscribe. A big thanks to PCBWay for sponsoring this video. Check them out in the description below for your exclusive discount code, and I'll catch you again very shortly here on Maker's Muse. Bye.